Hi learners, welcome to the course. Our today's topic is data mining functionalities. Myself Priyanka Gupta. I am working as assistant professor in Department of Computer Science and Engineering Data Science at Institute of Aeronautical Engineering, Hyderabad. So we'll cover the today topic data mining functionality types. Data mining functionality, in that I'll cover class concept descriptions, and in brief I'll cover data characterization and data discrimination. I'll also cover mining frequent pattern associations and correlations. So for that I'll cover the frequent item set, frequent subsequence, frequent substructure, and apart from that I'll cover association and correlation analysis, and then we'll cover classification and prediction for that. So let's start. Data mining functionalities. So basically data mining functionality that is used for to specify a kind of some of the types of pattern. So that is going to be found into the data mining task. So what are the data mining tasks we have completed? In that we have what are the functionality of that? Because of we have to collect types of patterns, right? So data mining task can be classified into the two of the types. First is descriptive and second is predictive. So what about descriptive? Descriptive mining task that categorize the general property of the data in the database, or we can say data warehouse. So it also includes the certain knowledge, certain of the information. So by that we can understand what is happening within the data warehouse or data base, and the data within the data that is without a previous data. So that is nothing but what is going with the live data, what is going with the transactional data. What are the information about that, what are the knowledge of that, we need to extract. So in that descriptive, the certain knowledge will be gained. The common data features will be highlighted into the data set, right? So what are the common functionality, functions, what are the different types are there, so that will be carry forwarded into the descriptive part of the mining. That is the task. For example, if we will take the example like first is count, right? So for count we have to gain the certain knowledge about the what is going about the count, how what are the databases there in the data warehouse, average, right? So these are the some example of descriptive. So these tasks, what I have told you, these tasks present the general property, the data to be stored into the database. So the data descriptive tasks that are used to find out the pattern in the data. So how we'll get the pattern? We'll use the certain type of algorithms, that is cluster, correlations, trends, that is pattern, and anomalies. So by these of the algorithm, we will going to find the different pattern. What is predictive mining task? So basically the predictive mining task that is performing the inference, that is performing the syntax. So the inference of the current data, that is in order to make we have to make some of the predictions for the future. So that is nothing but in that we have to make some of the inferences on the basis of current data. This type of predictive mining task that is also going to help that the developer to provide unlabeled definitions of attributes. So what are the attributes are there that is unlabeled? By the predictive data mining analysis, we are going to know, right? So based on the previous test, the software that estimate the characteristic that are absent. So what are the data is absent, what are the different attribute are absent or not having the label. So for that type of knowledge, we are using the predictive data mining task. So predictive data mining task predict the value of one attribute, that predict the value of one attribute on the basis of value of other attribute. So what does it mean? Which means that is the first attribute is nothing, but that will be depend on to the second attribute. So first attribute will be the target or dependent variable, right? And that will be the other attribute. What will be that attribute used for the making the prediction? So that will be the independent. So what are the attribute we know that we call as a dependent variable, target variable, and on the basis of that we are going to predict some of the some of the predictions. So the variable will be the independent variable. The attribute will be the independent variable, right? So the previous data mining task is nothing, but in that we are going to take more than two we can take. But for example, I am telling you the one of the attribute will be depend on the other of the attribute. For example, judging from the findings of a patient medical data, so that is in that we will see that he is suffering from the any particular of the disease. So the patient, he is suffering from the any particular type of disease. So that is depend on the he is suffering from any particular disease. So we have to know about the disease. What is disease he having? So the disease will be the type of disease will be depend on the how severe he is affected with that. So that will be the independent, and the disease, the type of disease will be the dependent variable. Data mining functionality as described as, so the first is class and we can say concept description. So class and concept description, in that we are using the classes, we are using the definitions, so that can be correlated with the results. So that will be correlate, mean that will be dependent on the another attribute. So by the mean of that, we can say the classification, classes and definition will be the correlated while we are going to predict about the results, right? So in the simplified way, we can say the descriptive and yet accurate way, it can be helpful to define the individual groups and concepts, right? So it will be helpful, it will be very, very helpful and to define the individual groups and concepts. So for example, if we'll take an example, in the electronics store, classes of items for sale include the computers and printers, and concept of customers include the big spenders and budget spenders. So here we can classify what are the classes are here. So here classes of items will be the sale of computer and printers, right? And the concept will be that for the customer, that including big spender and budget spender. So two type of customers are there. So like that, the concept and concept description will carry forward. So these classes or concept definitions are referred to as a class and concept descriptions. So these descriptions can be derived using, so we can derive these of the description using data characterization, data discrimination, and the combination of both. So what is data characterization? By summarizing the data of these classes under some of the study, that is often called the target class. So in that, the target class study, we have to study the target class and then we have to summarize the data for that particular class. right? So what is discrimination here? So by the comparison of target class with one of the set of comparative class, we can say some of the time contrasting class. So we will get the we will get the summarization of data on the basis of comparative class, a set of comparative class. So that we have to compare with target class, right? And both of the combination will be the data characterization and discrimination combination. So for example, if we'll take an example of that, to study the characteristic of software products. If you're going to study some of the software product with the sales, so that will if that the increase will be by 10% in the previous year, so the data will related to the such products can be collected by executing an SQL query on the sales database. So we will get the data related to that. What is the previous year calculations, because the sales were increased by 10%. So we need to take the SQL query for that, right? So after that, we'll be able to find the exact result. The output of that data characterization can be presented into the form of various forms. So for example, that includes pie charts, we can say bar chart, curves, multidimensional data cubes, and in the form of multidimensional table and cross tabs. So in the form of that, we can represent that type of data characterization while we are writing the SQL query for that. So that was all about data characterization. So we'll go into the deep of data characterization. So basically that is referring the summary of a general characteristics of we can say feature of a class or target class on which we are going to study about the data, right? So what is a target class? The some of the target data from the all of the data warehouse, on that we are going to study about some of the some part of the for to know the characteristics of that. So that is nothing but the summary of general characteristics. So that type of data that is corresponding to the user specified classes is generally that is collected by a database query. So what I have said in earlier example, we need to write a query for that. If in the electronic store there is a sales increased by 10%, so we need to write the query. Then we will get the result for that, right? And we can also represent that into the form of some of the graphs and some of the different forms, right? So the output of this characterization will be presented into the multiple forms, right? So for another example, if you are taking to study the characteristics of a software product whose sale increased by 15% 2 years ago. So if that is another example. So that anyone can collect these type of data related to such products that is running by the SQL query. So we need to write the query into the TMQL language for that. So the query will from the query we can predict about what are the results for there, right? We can know about the past results are there. Data discrimination. So we'll go into the depth of data discrimination. So basically the data discrimination that compares common features of class which is under study. So what are the target classes there? So basically that common features will be carried out for that, right? So the output of this process can be represented into also the many forms. So bar chart, curves and pie charts, right? So as earlier as discrimination, characterization. So it is comparison of general characteristic of data targets, right? Target class data objects with the general characteristics of objects from one and a set of contrasting classes, right? So the target and contrasting classes can be represented by the user, right? Obviously, if you are going to study about the database, So we'll get the target class and constructing class. So on the basis of that, we can predict about the result. So and the equivalent data objects that will be fetched from the database query. How a discrimination descriptions will get the output, will give the output. So the discrimination description expressed in rule form are referred as a discriminate rules. So by the writing discriminate rules, we will be able to find the descriptions of the output, for the output, right? So second is the second functionality is mining frequent items, patterns, associations, and correlation. So what are here frequent patterns? Mining, we can understand. We have to mine the data. We have to mine the patterns, different patterns we have to fetch. But what is frequent patterns here? So the frequent patterns are nothing but things that are found to be the most common in the data. So what are the data is available in the database? The most of the common features are there. We have to extract that are nothing but the patterns of that, frequent patterns of that. So that will occurring frequently, right? So first in that, we can take the first example for mining frequent patterns. So there are three types of frequent patterns, right? So first is frequent item set. So basically this applies to a number of items, as name suggests, item set. So that that depends on that applies to a number of items. So that can be seen together regularly. So some of the items that can be seen regularly. So for example, milk and sugar. So for any of the we can say in any of the store we are going, so the milk and sugar will come together, right? So the number of items then can be seen together is frequent item set. What is frequent subsequence? So this refers to the pattern series of pattern. So that often occurs regularly. For example, if we are going to purchase a phone, obviously we are going to buy a back cover for the phone. So that will be the subsequence for that. That will be the pattern series for that, right? So that is a difference also from the item set and subsequence. So another is frequent substructure. So it refers to the different kinds of data structures. So for example, tree, for example, graphs. So that may be combined with the item set of subsequence. So if we are going to present different subsequence together, so the substructure will carry out. So different kind of data structure will be shown from on the basis of such of the trees, such of the graphs. So that is nothing but the substructure of the frequent item sets. Second is association analysis. So this process, the association analysis process, that includes the uncovering the relationship between the data, and then it is going to decide the rule of the association. What is the association between the data? So the rule also it will be carried out here, and the relationship will be uncovered from this process. So it is a way of discovering the relationship between the various of items. So for example, it can be used to determine the sales of items, so that are frequently purchased together. So for example, if we are going to purchase the milk, obviously we are going to take the bread, we are going to take the sugar, right? So that is the frequent item set. So the sales of items that are frequently purchased together. So the relationship between these are the both items will be carried out in the association analysis. For another example, if you are taking another example, suppose a marketing manager is there. So he would be like to determine which are the items frequently purchased together within the same transaction. So the marketing manager, he'll be able to find, he have to actually find out what are the items is going together uh, while a customer is going to buy the some of the items from the store. So for example, the rule is written here, in that voice x comma computer, that depends on voice x comma software. So here the support we have calculated, that came out as 1% and confidence that came out as 50%. So the support and confidence we have covered in the earlier of the classes. So we can understand how we have calculated the support apart from that rule and the confidence. So here x is the variable that is representing a customer. So here x is nothing but the customer, right? So these are the rules written over here. So if if the customer is going to buy a computer, that is also going to buy a software, right? So that confidence will be the 50% and support will be the 1%, if we'll calculate that from the different of the formulas. So here the 50% confident, that means if a customer that is going to buy a computer, there is a 50% chance that he is going to buy a software as well, right? So the confidence is nothing but the surety that the customer is going to buy a computer, that is obviously by the 50% chance he'll buy the software also, right? So here support of 1%, that means that the 1% of all the transactions under analysis that has showed that computer and software were purchased together. So there is a 1% of the transactions analysis that the customer have purchased computer and software together, right? So this association rule involves the single attribute or predicate. So here a single attribute is calling as a predicate. So that is here by. We have written by. So that is nothing but the predicate in this association rule. So what have written in the earlier slide. So in this, the by that is going to repeat, right? So here we have written 2 of the times the same word by. Okay. So association rule that contains a single predicate are referred to as a single dimensional association rule. Okay. So if you're going to drop the predicate notation, the above rule can be written simply. So how it can be written? It will be written as computer depends on software, and in square bracket 1%, 1% and 50%. So 1% is the support and 50% is the confidence, right? Support and confidence. So same of the rules we can write in this form also, right? So suppose instead that we are given the all electronics relational database related to purchase, a determining system may find the association rules like age of x comma 20 to 29, right? That depends income x comma 40 to 49. They both inclusion depends on the boys x of laptop. When we'll calculate the support from the formula and confidence from the formula, the support we will get as 2%. The confidence we will get as 60% from this association rule, right? So here the support that the support that depicts the 2% of the purchases that is going to take going to the age and income that is having the same age group and same income in between, that is going to buy a laptop. And the 60% confidence is that obviously the these type of customer, this age group of customer, those are having this 40 to 49,000 salary, they're obviously going to buy a laptop. So that was the rule, association rule depiction. Correlation analysis. So correlation is a mathematical technique that can show whether and how the pairs of attributes are related to each other, how they are correlate, how they are relative to each other. So that is nothing but the, if one item is dependent on the other item, that will be the correlation between, there will be the correlation between them. So here is a mathematical formula technique to identify that. Classification and prediction. So that is a second part. So classification is the process of finding a model. So in this functionality, the classification is a process of finding a model that is going to describe and distinguish the data class. The data class for the purpose of being able to use the model to predict the class of objects, so whose level is unknown. So what does it means? It means the classification is going to find a model that is going to describe the data class, right? So on the basis of the class level that is unknown, right? So it is going to predict the categorical class label. Categorical class level. So basically the classification will work on the categorical type of data types. Categorical data types. So it also classify the data that constructs a model based on the training set and the value class labels in a classifying attribute and use it as a classifying new data, right? So that is going to classify the, it classifies the data model based on the training set, and it will be classify attribute and it will use as a new data. So it is the process of finding a model or function, we can say, that is going to describe and distinguish the data classes and concepts, right? So the model are derived based on the analysis of set of training data. As I have said, that is a combination of training data, for example, data objects for which the class levels are unknown. So it is basically derived from the analysis of set of training data. So how is the derived model represented? How it will be represented? So the derived model can be represented in the various of the forms, such as we can use the classifications rule. Here we have to write the if-then rules, right? That can be represented by decision tree. That can be represented by mathematical formula. That can be represented by neural networks and many more. So on the basis of these of the rules and we can say graph and trees, we will be able to model these of the derived models. Okay, so the all of the rules will be represented by this model, right? So these are the some of the various form to represent that. So a classification model can be represented in these of the forms. So first we have taken the if-then rule. For example, the student in bracket class comma, that is undergraduate, and the combination is concentration in bracket level high. So that will depends on class A. That will come into the class A. Second is the student who is having the class undergraduate and in the combination of concentration level is low, that will be in the class B. So for the student that is having the class postgraduate, that will come into the class C. So these are the if then rules for to depict. These are the some of the represent the rules. These are some of the models. So this is nothing but the model representation in the form of some of the if then rules. Decision tree. So what is decision tree? A decision tree is a flow chart like tree structure here where each of the node that denotes a test on the attribute value. Each of the branch represent the outcome of the test, and the tree leaves that are going to represent the class and class distributions. So we can see in this example of figure, here the age is the root. It looks like a tree. Here root is a age, and then it is divided into the young and old. That is nothing but the branches of the tree, and again it will having the leaves that are nothing but the leaves. The circle like structure, that is nothing but the leaves. So the leaves will be the class A, and the class B that is having the high and low representations, right? So on the other hand, the old is classified into the simply a class C leaf. So that is the depiction of the one of the decision tree. For example, if age of X of youth and income of X of high, that comes under the class of X of A. So here X is nothing but a student, right? A student. In another rule that is written as a if youth and low income low combination will be there, then it will come into the class B. The middle aged come into the class C. The senior will come into the class C. So in this decision tree, we can see like age is divided into the youth and middle age as well as senior. So the middle aged and senior will come into the class C. The youth will depend on the income attribute, and then it will be classified into the high and low, and that will come into the class A and class B. As earlier example we have also seen. So same example, these are the rules, these are the model that is depicting the whole of the model into the form of this tree-like structure. Neural network. So a neural network basically used for classification. It is typically a collection of neuron-like processing units. So here, that's why we call as a neural network. Network is nothing but the combination of some of the nodes, and neural is nothing but it is a we can say neuron-like processing units model. So basically it is based on the classification and typically a collection of neuron-like processing units with weighted connections between the units. So that is unique here, that in this example, in this figure we can see, and this is a neural network, right? That is having the age and income at A1 node and A2 node that connected with the A3, A4 and A5, and that all connected with some of the point. So these are the weighted connections between both of the units, right? So that will also depend on to the A6, A7 and A8. So that is this thing we can call as a weighted connection, right? So that is nothing but the neuron-like units. So basically it looks like a neuron system, so that is calling as a neural network. The cluster analysis. What is cluster analysis? In classification and prediction, that will be analyzed based on the class labeled data objects. So the if the attribute will be labeled so that we will be able to do the classification as well the prediction for the same of the data objects model. So where in classification and prediction analyze, class level data objects, where as clustering analyze the data objects consulting a known class level. So here we know the class level. So for example, in this figure we can see three of the clusters have made. That is cluster 1, that is cluster 2, that is cluster 3, right? So here some of the objects are there. These are nothing but the outliers that are beyond to the some of the model that are beyond to the cluster and model. So that is nothing but the outlier. So these are the three cluster will be depicted on the basis of the class labels that is known. So the objects are grouped based on the principle of maximizing the interclass similarity as well as minimizing the interclass similarity, right? So that is a cluster of objects are formed so that objects within a cluster have high similarity in compare to one another. In compare to other, it is having the similarity, and but are very dissimilar to the objects in other of the clusters. So the for the example in the figure, the objects were grouped on the basis of the maximizing the interclass similarity and minimizing the interclass similarity, right? So that is a cluster of objects that have formed and on the basis so that objects within a cluster have high similarity and in compare to each other, and but that will be very dissimilar to the other clusters. Fifth functionality is outlier analysis. So a database may contain data objects, right? So that don't comply the general behavior or model of the data. These data objects are outliers. So in the earlier example we have seen the outliers were there in the classification, right? So these data objects are nothing but the outlier. The most of the mining methods discard these of the outlier. We need to discard those of the errors that are the outliers, that are the missing value. So as noise are exceptions, that is called also as a noise or exceptions. So the analysis of outlier data is referred to as a outlier mining. So we need to mine these of the outlier, and we have to discard these type of outliers from the model. Outliers may be detected using the statistical test that can be detected by the some of the statistical tests are there that assume a distribution, a probability model for the data, right? So we need to use the some of the statistical methods. We need to use the probability model for the data. We can also use the distance measures. So we are having the sum of the distance measure formula where the objects that are remote from any of the other cluster that are considered as an outlier. So on the basis of the distance that is having that will be remote from the other cluster, that will be considered as an outlier. So rather than using the statistical and distance measures, if you're not using distance and statistical measure, so that will be identified on the basis of distance also. So there are some methods to measure these are the outliers on the basis of distance measure. So that are Manhattan, that are some Minkowski method, right? So on the basis of that we can measure the distance also, and we can get the outlier for that. So density based methods may identify the outliers in a local region. So if some of the local region is there, we can also apply the density based methods, although they look normal from a global statistical distribution view. So if we are having these of the functionality, if we are having these type of problems, if the data looks like from the globally looks like simple, but in the local level it is looks like a outlier, so we need to apply the outlier based density based methods for that. Sixth functionality is evaluation analysis. So basically it defines the trends for object. So on the basis of that the behavior changes will be counted. over the sum of the time. So if the behavior will change for the certain time, the trend of object will be carried out for this evaluation analysis. So for example, the study of stock exchange to identify the stock evaluation. As we know, the stock exchange will work on based on the time. So it is a matter of time. So the stock will be up and stock will be down. So in the fraction of seconds, the stock will be down, the stocks will be up. So on the basis of these of the behavior, the trend, we need to by the evaluation analysis, we need to identify the trend for the same. We need to study about the changes of that behavior, and we need to take the pattern for that. So by the evaluation analysis, we will able to do the same. We will able to find the trends for objects. So that was all about the data mining functionality. These were the some of the 6 functionality, and either they were classified into the other some of the methods. There were some rules, methods. So by the basis of that, we will be able to mine the data in the data mining. So this was all about the today's class. We'll meet in the next class. Thank you for watching.
Like, share and subscribe. Hit the bell icon for more updates.